Okay, so welcome everybody. This webinar is the second of a series of webinars organized by the Copkit project for law enforcement agencies and project stakeholders. Today, the main goal is to give an overview on the fundamentals of a knowledge discovery tool as part of the Copkit solutions explained in the previous webinar. We will show some fundamentals about the tool and how it can be employed to discover new knowledge in the form of relationships or patterns emerging from the analysis of Darknet advertisements, with a particular focus on firearms trafficking. Let me introduce myself. My name is María Dolores Ruiz, and I work at the University of Granada. I am the responsible of the knowledge discovery development task within the Copkit project. Through this webinar, we pursue to follow the following objectives. We will start with a brief project presentation. Then I will continue to explain how knowledge discovery can help in data exploration within Copkit. For that, I'm going to present one of the knowledge discovery tools developed in Copkit, which is called the frequent item set and association rule discovery approach. And I will end with a demonstration of this approach to analyze Darknet advertisements. After that, we will have time for questions and answers. But you are free to type questions in the chat whenever you want. The Copkit project is a Horizon 2020 project that tends together law enforcement agencies that are end users, industry, academia, and research institutions to create an intelligence and knowledge ecosystem for law enforcement agencies in order to support prevention, investigation, and mitigation in the context of the fight against organized crime and terrorism. We are collaborating together 18 organizations from 13 different countries, counting also with the collaboration of external support from the end user and stakeholder advisory board, with Europol as the leader of this board. One of the conclusions drawn by the law enforcement agencies in a previous project was that strategic and investigative analysis were intrinsically interconnected. So in Copkit, we are trying to close the cycle shown in the slide within these two important aspects of the analysis. In this regard, we are producing procedures and tools capable of produce and share knowledge. It is in this specific objective of knowledge and information production where we are going to focus in this webinar. You can watch the previous webinar where we explain the different objectives that we pursue in Copkit. In particular, for fighting crime, we try to produce models and extract patterns with the goal to obtain what we call context knowledge in order to help in the investigative analysis. We called this approach the early warning, early action-led policing, as you can observe in the upper right corner. One important part of this approach is the production of knowledge in both sides of the loop. For that aim, one of the objectives of the project is the elaboration of a toolkit in order to collect, extract, analyze, discover, assess, and predict by means of suitable tools to enable the injection of knowledge in all steps of the investigation process. So in general, knowledge discovery aims at developing methodologies for extracting useful knowledge from data. In Copkit, we employ knowledge discovery methods as a first step in the exploration of collected data from the environmental scanner. This information can be later used to refine the research process, focusing on those parts revealed as novel or interesting, and also as an enriching piece of knowledge in later steps of the investigation. Regarding the use of knowledge discovery methods, there is a wide variety of methods that can be employed for obtaining information from data. In the slide, you can see some of them. For the first group of methods, there is a need of feeding the algorithms with information in order to adjust the models. For the second group, there is no need of extra information, and therefore it is used for exploratory purposes. In this webinar, we are going to focus on a non-supervised method that enables exploring the data, giving patterns of concurrence in the collected data. In particular, we will focus on how searching for frequent items and association rules. And with those, we can obtain interesting knowledge in a set of collected advertisements. So in general, knowledge discovery tools offer an easy way to find information in big data volumes. In particular, our tool will extract or discover information in a non-supervised way in the form of relationships and patterns. For the specific case of finding insights in the ambit of arms trafficking, this tool can be useful to find relations between items, like for instance, to know which day is more likely to find an ad offering a specific type of arm. For example, to find connections between two or more entities, for instance, two suspects, two cases, or to group similar nodes. For instance, like putting together similar users of the dark web forums. In particular, we are going to focus on what kind of information can be discovered in a corpus of advertisements found in Darknet. If we have a look to this example of advertisement, although it is not from Darknet, in the body of the ad, there is information that can be captured by a web scraper. For instance, it contains a descriptive title, a price, where the article is located, and the places where it can be sent. We can also find to which category the advertisement belongs, as well as some information about the seller, for instance, in the right part. Additionally, there are some metadata about the advertisement that can be also collected, as for instance, the timestamp indicating when the ad was posted. In this way, the idea is to collect all this data and process it in order to structure the data in a way that can be processed by some knowledge discovery tools. So once the web scraper has collected a sufficient number of advertisements, they have to be processed by using natural language processing tools that are usually adapted to handle with a specific vocabulary attending to the type of article or service offered in the ad. In this webinar, for explanatory purposes, we're going to focus on the topic of arms trafficking. For that, the data that we are going to use are samples of advertisements containing information about arms or ammunition, and where the information about the vendors are anonymized. Therefore, the general idea is that if we imagine that we have collected a sufficiently big amount of advertisements that could represent the type of ads posted in the Darknet, the relationships discovered in the data can be representative of what is happening in Darknet. But what kind of relationships or patterns can we find? Sorry. What kind of relationships or patterns can we find in a set of Darknet advertisements using this knowledge discovery tool? we are going to refer to two different pieces of knowledge. First one is called frequent item sets, where it can be discovered the frequent concurrence of the items collected in the advertisements. That is, locations, type of firearm, vendors, etc. For that, we are going to use a measure representing the percentage of ads containing those items together. For the case of association rules, the knowledge that can be discovered are directional relations between the items, having two different measures to assess the goodness of the association found. We are now going into more technical details about these two types of techniques, and we will see afterwards the results of their application into a set of data comprised of advertisements from different marketplaces in the darknet. So before presenting the knowledge discovery tool, we have to ensure the fulfillment of some requisites or requirements about the data. Data should be stored in a structured dataset, where the rows represent the transactions and the columns represent the attributes. The attributes may have different values that can be categorical or numerical. Following with the sample of Darknet advertisements, each individual advertisement will be represented by a transaction, that is, a row in the database. And for each pair of the form attribute value, we will obtain an item that will be represented by a column in the database. Examples of items can be the pairs firearm Glock 26 or market nucleus, being both categorical attributes. And for instance, price between 200 and 500 euros can be an example of a numerical value, where in this case it can be considered an interval to represent the range of the numerical value. Once we have the data structured in that way, it is easy for the tool to transform a database like this one, like the one shown here, or like the one shown in the previous slide, into a Boolean database like this one, where we are going to have 1 in the position I for the row and j for the column, representing that the transaction I contains the item j. The 0 will represent the opposite, that is, that the item j is not present in the transaction I. This Boolean dataset enables a more efficient storage, since for its representation with ones and zeros, we can use bits to represent them. This is extremely important when large volumes of data has to be analyzed. Then we can now uncover the hidden frequent item sets and association rules in the database. For the frequent item sets, as the name indicates, the tool analyzes all the possible combinations among the items and find the most frequent sets of items that co-occur together. For that, we employ an assessment measure called the support of an item set. This measures the probability that a transaction contains the item set. That is, the percentage of transactions containing the item set. Therefore, in order to obtain the set of frequent item sets, the user has to impose a threshold called minimum support, indicating the minimum percentage of transactions containing the item set. Common values for minimum support are 0.1, 0.05, etc., which impose respectively that the 10% of transactions contain the items of A, or that the 5% of transactions contain or satisfy the respective items. To uncover the hidden association rules in the database, also called if-then rules in some ambits, The tool analyzes all the possible combinations among the item sets and finds the associations between two item sets. This association is represented by an arrow and has a directionality. The item set A, or the left part of the rule, is usually called the antecedent of the rule, and B, or the right part of the rule, is called the consequent. So the first step is to impose that the support of the rule exceeds the imposed threshold, also called minimum support, indicating the minimum percentage of transactions containing both item sets, A and B, at the same time. Additionally, its confidence has to exceed the minimum confidence threshold imposed by the user. The confidence measures the percentage of transactions that containing the antecedent, that is A, also contains the consequent, B. Therefore, in order to obtain the set of association rules, the user has to impose two different thresholds called minimum support and minimum confidence. Common values for minimum support are 0.1, 0.05, in the same way that we did for the frequent item sets. And common values for minimum confidence are 0.9, 0.8, etc., indicating the minimum percentage of transactions that, containing the antecedent, also satisfy the consequent. Now, before presenting the demonstration video about how to use the knowledge discovery tool, we describe a little bit the data to be analyzed. In this video, we have uploaded a dataset called ngram for illustrative purposes. This dataset is publicly available and contains advertisements from Darknet between 2015 and 2016, containing firearms-related advertisements. This includes many arms and ammunition selling advertisements. It can be seen the type of attributes collected in this dataset, which includes the name of the market, the vendor name, the price, which will not be used because it is not in our right format, the name of the product, its description, from where it is the product being sent, some keywords, and as a category and the time when the ad was posted. Some of these attributes have been eliminated and others have been processed in order to first accommodate the data to the tool, and secondly, to obtain more interesting associations involving this item. A capture of the current structure can be seen here, where the category of the firearm has been added, taking into account the description of the ad and the keywords by using some natural language techniques in combination with some clustering tools. Taking also into account the advertisement publication date, we have obtained three different attributes: the month of publication, the day of the week, and the daytime when it was published. That is, if it was during the day or during the night. So now we are going to watch the demonstration video about how to use the knowledge discovery tool. The first step is to upload the database containing the data to be analyzed. We first upload a dataset called ngram for illustrative purposes. Although already uploaded databases can be also selected in order to run a new experiment, for that, we can see the available datasets in its corresponding tab, as you can see. Once the data is selected, we have to set minimum threshold for the minimum support and minimum confidence. This choice will depend on the dataset to be analyzed. We recommend to start with higher values for the thresholds if very few results are found, and we can afterwards modify these thresholds in order to soften the restriction. As we can observe, there is no distinction in this part between the frequent item set or the association rule discovery. The tool will use the minimum support threshold for both functionalities. We recall that the minimum support is usually set below 0.1 and the minimum confidence above 0.7. Although these values can vary a lot depending on the set of obtained results. We press the green button and the experiment is executed. The end of the experimentation will be shown at the right part. The time spent for the tool will also depend on the size of the database. The higher the number of attributes and transactions, the higher the consumed time by the tool. In the second tab, called Experiments, we will be able to visualize the results obtained for draft threshold selection. Although previous experiments can be also selected for their inspection. Currently, the tool shows in the form of table the obtained results. In the upper part, we can navigate among the frequent item sets, and in the bottom part, among the association rules. In both cases, the validity measures are shown. The support for the frequent item sets and support and confidence for association rules. The higher both values will indicate that stronger is the association between the item sets. Additionally, this visualization enables to rank results according to some preferences. For instance, we can rank by the support of the or by the confidence and also alphabetically by the attribute. In this way, we can search those rules or frequent item sets that we are more interested in. Here in this video, we can see the results obtained for two different combinations of thresholds, and we are going to inspect some of these results that we have selected in the next slide. For instance, we have selected some frequent item sets, and we are going to explain their interpretation according to their assessment measures. For instance, the item day week equal to Monday has been found with a support of 0.2. This means that this item is present in the 20% of the ads. Other examples are the item market alphabet, which in conjunction with the daytime night, which was found in the 43% of the ads, meaning that the 43% of the ads of alphabet are posted at night. Another example is the joining appearance of market alphabet and the arm type handgun in the 35% of ads. Regarding association rules, we have selected two rules relating the publishing day and the time of day when the advertisement was published. These two rules has a moderate confidence exceeding the 75% and relates, in the first case, the ads posted on Monday, which are more likely with a 78% to be posted during the day, having the 16% of ads supporting this. And we have found also the relation between ads posted on Saturday, which are more likely with a 76% to be posted during the night, having the 11% of ads supporting this. We have also selected two rules that we want also to show relating the vendor with the sale of ammunition, like the following. When the vendor is a certain user, it is more likely with a 96% of confidence that the ad offers ammunition, having the 8% of ads supporting this. And when the vendor is the same user, it is more likely with a 96% of confidence that the ad offers ammunition can be shipped from any place, having also the 8% of ads supporting this. As we have seen, this tool can be used for exploratory purposes and can be also improved with some additional features. Here, we leave some directions for the future developments, which will involve a graphical visualization of the results, like for example, this graph, where the size of the circles represent the support of the rule, and the color, the intensity of the confidence. That is, the nearer to red, the higher the confidence. We also plan to add some filtering specification before performing the analysis, and also the development of automatic algorithms for interval specification for those attributes containing numerical values. For instance, in the case of the price attribute, it would be interesting to specify different intervals indicating if it has a low price or a high price depending on the specific type of firearm.